Hi, I'm John McGregor. I'm a product trainer with the Sennheiser SoundAcademy. And in these series of videos, we're going to introduce you to the Digital 6000 system and talk about all the benefits the system has. In this video, we're going to focus on the audio quality of the Digital 6000. For us at Sennheiser, audio quality is everything. We do not make compromises easily, and whenever we do, we only do it when we're certain that the audio quality will still be the best on the market. With the Digital 6000, we are offering the same audio quality that you have seen in the Digital 9000 in long-range mode. How does digital transmission differ from analog? With analog technology, we had to work to keep the dynamic range within a strict legal bandwidth of 200 kHz. This meant we had to use companders and pre-de-emphasis, which were optimized for vocal speech frequencies and found their limits in complex audio signals with lots of high frequencies. With digital transmission, these limits are no longer a concern, and any compromises we had to make, and thus any artifacts that were introduced into the audio signal, have now been overcome. This all means that you benefit from greater audio quality that is nearly comparable with a wired microphone. The legal requirements for digital transmission are still the same as for analog. We still only have a 200 kHz window in which to work. To ensure we can keep the audio quality high, but at the same time ensure maximum reliability of transmission, even in noisy RF environments, we have chosen to decrease the data rate by using a specifically created audio codec.
In this short video, we will show you briefly how we transmit a digital signal on RF. First, it must be mentioned that we do not actually have a digital transmission. We are still using an analog carrier signal, but we have modulated it in multiple ways to encode the digital audio signal. There are numerous ways of modulating the signal to allow digital audio to be transmitted, and with the Digital 6000, we use multiple modulation methods to allow us to get the required audio quality during the transmission process. In this video, for demonstration purposes, we will show you only one of these methods, phase shift keying, or PSK. As you will see from the diagram, we have a fixed carrier frequency that will be modulated by the digital audio signal. For this example, we are using phase shift keying. For this, we modulate the phase of the carrier frequency when required by the digital signal. You will see that we have shifted the phase of the carrier wave by 180 degrees each time we must represent a 1-bit position. As we introduce higher levels and further models of modulation, it is then possible to encode complex audio across a carrier frequency and still allow for perfect sound every time.
What codec is being used inside Digital 6000? So what exactly are we talking about when we say we use a codec to reduce our data rate, yet keep the audio quality at an unmatched level? A codec is a piece of hardware and software that is used to encode and decode a data stream. The idea is to compress the data stream to reduce the transmission bandwidth. Our challenge is to offer the best audio and transmission performance within a bandwidth of 200 kHz. For this requirement, we have created CDAC in conjunction with the Fraunhofer Institute. We did this as all existing codecs on the market did not meet our strict requirements. With the development of CDAC, we have achieved a unique combination of properties that is yet to be seen on the market outside of Sennheiser systems. We have top quality audio matched to high RF robustness without adding more latency to the transmission. The unmatched performance of CDAC is only available with Digital 9000 and Digital 6000.